Hey, Code in Place, welcome back to another wonderful week. This is a very exciting week. We get to introduce you to graphics for the very first time. You guys have worked hard. You guys have built up a solid foundation. It's now time to celebrate. And the way we're going to celebrate is we're going to draw some beautiful shapes on the screen using the programming that you know. So let's jump into things. Oh, yeah. To whet your appetite for graphics, I want to show you the sort of program that you'll be able to make with the concepts you'll learn in this week and next week together. So with those ideas, you'd be able to make this. This is a Python program. It's not all that different from the console programs you've written. Of course, there's this one big change, which is that instead of just printing things to a console and getting input, we're drawing things, rectangles and ovals. And instead of getting input from the console, we're having the user interact with the mouse. This is a program that I wrote. It's based off of the classic, one of the first computer games ever made called Breakout. And it's written in Python, as you'd imagine. So stay tuned for the next few weeks and learn the wonderful joys of graphics, animations, parameters, so that you can make this too. Before we jump into graphics, I wanted to just share an interesting thing that Maron and I have learned in our long history of studying how people learn. As you may know, Maron and I have both thought very deeply about how people learn to code, and I'd like to share some of the insights that we've figured out over the years. So here's a graph of how long people in 106A took to finish a programming assignment that culminated in Console Academy, the one that you had to write earlier in this week. Now, that's a hard program, and for some people, they were able to figure it out pretty fast. But for others, it took them a really long time, and there's even some folks who have just worked on this for a really, really large amount of time. And I want to speak a little bit to how I think you should think about things if you find yourself spending more time in this than you expect others are. Because the story is actually pretty positive. To tell you the story, though, I'd love to jump out of 106A and into another coding platform called code.org. And code.org, you have students who are learning to program, but instead of learning Python, they're learning a drag and drop language. It still has loops, it still has if statements, still has statements. So it still is quite difficult, but it's just not in Python. What's really interesting about code.org is how many students have done this. So if this is every K-12 student in the US and each of these little figures represents 500,000 learners, the number of people who've tried one of their projects called Hour of Code is enormous. It's millions and millions of people. Now we're going to try and learn something about how humans learn from these millions of people. But before we do anything sophisticated, should we just have a moment of bliss and let's just watch a million people learn how to solve a 5-line computer program? Now, this is a visualization. These pink dots are students. At the beginning, every student starts with the same code, and they're all trying to get to the solution, which is over here. Every single one of these dots is some piece of code that the students could write on their way from the starter code to the final solution. When students make progress, they could move along the lines. That's what teachers suggest students should do. Or they might move off the lines, which would be them trying something that teachers didn't expect. Should we just watch all these people try and solve this problem? Let's go for it. So as I mentioned, every dot is a partial solution and people are trying to get to the very final answer. Pink dots are students. Let's go. A million people learning. Now you'll notice a lot of people start doing the same things, and there certainly is a contingent of folks who go right to the answer. But very quickly you see like some people who made different decisions and went different ways. And some people who go different ways, they continue to go different ways. And one of the realizations is before people get to this green dot, they can go lots and lots of different ways. You're looking at hundreds and thousands of people who are really feeling lost on writing this 5-line program. And there's a lot of things we can take away from this. One is just empathy. Like, this stuff is hard. We know it. We can watch it being hard. In fact, the person who took longest here was several complete days of full work just trying to get this one program to work. Respect to that person. The other thing to take away is there could be some structure to this. Maybe there's some pattern to how people are solving these problems that will give us a signal as to whether or not, let's say, they'll be successful 20 assignments into the future. So to try and answer this question, built a thing called machine learning algorithm, uses a little bit of AI. I'm not going to go into the details, but if you're curious, you can ask me on the forum. And this machine learning was going to look at people's process to see if we can predict how well they'll be doing in the future. It uses a thing called a recurrent neural network. Again, the details aren't that important. It was pretty good. It could look at a student's process and do a really good job of figuring out will they be able to solve the next problem, the problem after that, or even 20 problems into the future. The interesting thing, though, was at this point, we had this really smart AI algorithm that could look at how students tried to solve problems, and we could tell who was likely to make it. And then we could ask it questions. We could say, like, hey, AI algorithm, who do you think is going to be most likely to succeed? Uh, so we asked the AI algorithm this, and it gave us back what I thought was a pretty interesting answer. When we say the AI algorithm, hey, who's going to make it all the way through this coding curriculum? Not just a little bit of the way, but like all the way through. The AI algorithm did not return the student who made it to the answer first. Instead, the AI algorithm returned somebody who spent a lot more time on this assignment than most students. And I want to highlight a few things that this student went through. So this AI algorithm has picked this student out as the most likely to succeed. And the interesting thing about this student is this student didn't just start out with the wrong answer. Students started out with a really wrong answer. Students started out with two compound errors, and it took them a long time to figure out how to get this to a working solution. But I think the most beautiful thing about the student is that they did not give up. They did manage to solve one of their problems. They then took a wrong turn and tried an incorrect way to solve a different problem, tried it, realized it didn't work, undid it, and then finally found the solution. This person is substantially more likely to make it through the entire curriculum than somebody who just solved the problem correct in the first place. And I think that speaks so much to programming. It speaks so much to life and the beauty of the challenge that we take on. And if there was one takeaway for you in Code in Place, uh, it's probably this. Coding is a new way to think. I've seen 20,000 people learn to code. I know it's difficult, especially if you're coming with no background. It's just a really, really hard thing to do. But you're here because you're challenging yourself. You're trying to make your mind more adept at thinking about logic. You are trying to become that better version of yourself. That in itself is just a really beautiful, respectful thing to be doing. And then also, what I've learned from my research is that the challenge itself is sometimes the big takeaway. If you're finding this harder than others, you're probably getting the most out of it. If you are working harder than others, you're probably more likely to make it deeper into computer science. It is not the case that the people who find it the easiest now are the ones who are going to be able to have the big breakthroughs in the future. Often it's the ones who can work the hardest when they hit problems, try and work through that. So you guys can reflect on what that means for yourselves. But my big takeaway is just we're very impressed by you. You have our respect for working so hard. Keep at it, and we'll keep trying to give you all the content we can to make it as easy as possible for you to learn.